Hello, welcome to my first video. Today we're going to be talking about solving inequalities, section P2 in your book. LO stands for learning objectives. So your objectives for this lesson are that at the end of it you would know how to solve various kinds of inequalities, including absolute value, and you would also know how to solve polynomial and rational inequalities using the concept of critical values. Okay, the first thing I just want to make sure you understand here is the idea of interval notation. So just to kind of give you a little bit of a background of this, you are used to writing inequalities in standard notation. So for example, if you wanted to write that x can be any number greater than 3, you would say x greater than 3. So that's standard notation. Now, interval notation is written a little bit differently. So if you think about what a number line representation of this would look like, the number line representation of x is greater than 3 would look something like this, right? So now if you look at this interval or this number line from left to right, you can see that the solution set starts from numbers bigger than 3. So on the left side, I could say that the interval starts on the left side at 3. And then it goes to the right all the way to infinity. So we would say infinity is the right side. So this is the equivalent interval notation form of this standard notation. Okay? Now, because the right side goes to infinity, we would say that this is an unbounded interval. Okay, a bounded interval would be one that has an actual value on both sides, so that the range of values is within two finite numbers. So I recommend that you look over example 1 on page 15 and just look at the 4 different examples there of unbounded intervals, ones that are inclusive of the boundaries and ones that are not inclusive of the boundaries, and how they're represented with parentheses or brackets. So maybe take a moment, pause the video now, and read example 1 and make sure you understand it. Okay, so as not to make the video too long, I also recommend that you look over examples 2, 3, and 4 on your own. They're fairly simple, so you should not have a problem understanding them. Okay, so now we're going to go straight to example 5, which is solving absolute value inequalities. So let me scroll this up now, and we'll start example 5 right here. Okay, so the idea with absolute value is you can look at it kind of systematically and have like a rule of how to solve it. So I know a lot of teachers just give you rules. So, you would do something like this where whenever you solve an absolute value inequality, you always write the same inequality as it stands, and then on the other one, you flip it and you make the other one negative. Okay, so now this kind of systematic method works no matter if the inequality is a less than or if it's a greater than. It doesn't really matter. However, I do not favor this approach from a conceptual point of view because I don't think it really helps you to think about what absolute value really means. So I like to think of this more in terms of absolute value conceptually refers to the distance that something is from 0. So in this situation, we're saying, what this problem is saying is that the expression x minus 5 has to be less than 2 units away from 0. Okay, now, if you think about a number line representation of this, okay, so let's say this is 0, okay, and actually in this case it's not 0, it's x minus 5 representing 0. But if you want this expression to be less than 2 units away, and maybe it is actually helpful to think of it as 0. So if it's less than 2 units away from 0, then that means that going to the right, it could go all the way out to where 2 is, so here's 2, or going to the left, it could go all the way out to where negative 2 is. But it has to stay within these boundaries between negative 2 and positive 2. So understanding absolute value as distance from 0, then, it would make sense for this problem to go about solving it like this. You put the expression x minus 5 in between 2 and negative 2. And then you just solve this compound inequality. So you would add 5 to all sides. This side would be 7. This side would be 3. And there you go. There's your solution in standard form. And then, of course, in interval notation, you would write it like this. Okay. Now, interval notation, sometimes it looks like an ordered pair, x, y. So, obviously, you just need to understand what the context is that you're writing it so that you communicate clearly. In the second example, you have an absolute value where it's greater than or equal to 7. Okay. So again, if you think about it from a conceptual point of view, you're thinking of if this is 0, this is 7, and this is negative 7. If you want to go greater than or equal to 7 units away, you would have to start at 7 and go beyond it to the right, or at negative 7 and go beyond it to the left. So therefore, you can see from my number line that there are two distinct intervals, one going left and one going right. And so the way you can express that is the one on the left is that x plus 3 is less than or equal to negative 7. Whereas the one on the right is x plus 3 is greater than or equal to positive 7. Okay, so this is two separate intervals. We're going to separate it with an or because they're non-overlapping. And we subtract 3 for this one. We subtract 3 for this one. And there's our solution. In interval notation, the left one starts from negative infinity, goes all the way up to negative 10. Or is union, and then the right one starts at 4 and goes to infinity. So that would be the equivalent interval notation.